Chapter 12, Lesson 2, we're going to start by doing the first part of this PowerPoint in class together. I'm hoping that we'll be together in a classroom where we can share in the excitement of making a box and finding the different volumes of the box through measuring. So there's no video for the first part, but let me give a video summary of the analysis, which is what's really important. So in class, we will go through the first set of pages, and let me zip through so you can see what we'll do together in class. We'll construct the box, and hopefully by the time you've watched it, this makes total sense. We've done this together, that you plotted points. You've let your calculator plot points, because for God's sakes, it's going to be a lot easier for it to for the calculator to do it. There's descriptions in writing, which I'm hoping we can do together in person, so that if not, we'll do it by Zoom and we'll make it work. But this can start feeling really dense. But if we do it together, it'll be easier. And you can see, yeah, it feels like it's kind of heavy whenever there's a lot of reading in math. But then the most important part is when we're looking at the graph, and it's kind of dark here in the image, but on your calculator you would see this. So we want to do some analysis of this. So what I've got here is at the very end, this singular page where we're going to analyze, we're going to do an analysis of this function. So I'm afraid it's tiny, so I've kind of darkened what it is. This x-intercept is -4. This value here, which is the top of the bump, maximum, is about -3.4 and 13.1. I've just rounded it to tenths. It's written hopefully in your PowerPoint to a few more axes. And let me get rid of that thing. And here's another x-intercept. This curve is tangent to this at an x value of -2. And here's another maximum. It's the top. This is a minimum. It's the bottom top. And then we come through another x-intercept of 0.3, about 0.3. So in the analysis, we want to look at a couple specific things. So let's start by talking about coordinates of extrema. Extremum is the singular. So we're looking at what's a maximum. So a local maximum is in its neighborhood. Neighborhood is a math term. It would be the highest value. Here's a local minimum in its neighborhood. It's the lowest value. Now notice this is not the absolute highest. There's other y values that are greater over here. This is not the absolute or global minimum, because there's values down here and over here that are lower. So we want to, if you're asked for the coordinates of the extrema, you want to find the maximum and the minimum values as coordinates. So there's the coordinates. Here's the coordinates of a local min. This is a maximum, it's the top. It's also a global. Let me move that over. You can see it's a global max. It is the biggest in this entire function. So 0.16 is the y-intercept, and that's the x-intercept. We want to also look at the intervals where the p of x, or the y value, is greater than 0. So what's interesting about this, even though we're talking about the y value, when we give an interval where y is greater than 0, we give that interval in terms of x. So we can see here is a region, a place where the y values are positive. Here's another place where the y values are positive. So in terms of x, we would say, and I'm not giving myself much space, I'm going to go down here where p of x greater than 0, okay, and I'm going to identify in terms of x this value. You can see the x value here is -4. So I'm going to say -4 is less than x, and that goes all the way up to -2. So this identifies in terms of x this interval where y is positive, where it's above the x-axis. I'm going to put a union. We've seen that before lots of times this year. Union I also want to include where -2 is less than x is less than 0.3. So all these places where this function is above the x-axis is where, I'm going to circle this, is where the y value, or p of x, is greater than 0. So you can see I've listed them in terms of x. Sandwich the x between -4 and -2. I want to go smallest to largest and use less than signs. X between -2 and 0.3, I'm going to use less than signs. Okay, now let's look at the second. Intervals where p of x is increasing. So let's write this down here. P of x is increasing. And I'm going to put an arrow up where it's increasing, where it's going uphill. Now you want to read the graph left to right. So I'm going to write up here, read the graph left to right, like you'd read in a book, left to right. So as I go left to right, and if I were traveling on this curve, am I going uphill? Then I'm increasing. If I'm going downhill, then I'm decreasing. If I'm going uphill, then I'm increasing, and so forth. So how do I identify the intervals where it's increasing? In terms of x. Even though I'm asking, where is the y value increasing? Where's it getting larger? I want to answer that in terms of x. So I'll say, well, here is where where we're going uphill. Here's where the y value is increasing up until this point. Then it's going to turn around and go back down. So imagine yourself pulling a sled up a hill. Are you putting it up the hill or are you sliding down? So again, in terms of x, it looks like this just keeps on going. There's no bottom value. So I'm just going to say x is got to be greater than, I'm going to put it this way, greater than infinity. I can't really put that there, but it's also less than negative 3.4. So I'm just going to say, I can't put an infinity in there, so I'm just going to say x is less than negative 3.4. This is where it's increasing. So it's decreasing for these x values between negative 3.4. You can see that's the x value right there, up till negative 2. So I'm not going to include that in the increasing. Union, okay, negative 2 is less than x, so x is going to be between negative 2, and where's the next value? It's going uphill. We're carrying that sled uphill up until where x is negative 0.3. And I'm including that 0, negative 0.3. So that's where it's increasing. So I'm going to say the function is decreasing. This is the last part, where I'm going downhill. Going downhill here, I'm reading it left to right. So that is where x is sandwiched between negative 3.4 and negative 2. And x is, here I'm increasing again, I don't want to include that. Here's where the x is negative 0.3. And then it looks like there's no other place where it turns around and comes back up. So this is the intervals where it's decreasing. If you're confused about how to determine whether it's going uphill or downhill, because it's kind of just a verbal, the way we really talk about it in calculus is if I were to choose a point, any point here, and draw the tangent to that line, tangent intersects one point, is the slope of that tangent positive or is it negative? Here it's positive. A positive slope means it's increasing. Now look at over here. If I were to draw the tangent, it's kind of hard, that's going to be a point of inflection here. So if I have the tangent, it's kind of hard to see where it's going to be. That's where the slope is negative. And so that function is decreasing. Notice at the minimum, the slope is going to be, it's going to be a horizontal line, so the slope's going to be 0. So here, maximum, slope's going to be 0. It's a horizontal line. These are going to be really important things, really important characteristics of the graph. You can imagine how a maximum value might be really important if you want to maximize profit. A minimum value might be important if you want to minimize costs. Maximum value might be important if you want to find out, how high that rocket goes in the air. So these are really important in the analysis of functions. Here's your y-intercept. I think you know how to find that. Here are your x-intercepts. Looks like you've got 1, 2, 3 x-intercepts. I hope this was instructive. This will set you up really well for that course we're all looking forward to down the road.